Nigel, thank you very much for the invitation, and it's my pleasure to tell a little bit about this topic here, smart systems for the automobile and the mobility system of the future. By doing that, I'm also, in a sense, reporting about what Elisabeth already announced, that there is a working group in EPoSS that we once was called the Automotive Working Group that turned into the Transportation Working Group recently, and that I have had the pleasure to coordinate a little bit since about 12 years. And we've gone through processes of promoting like the electrification, the automation of road transportation, for example, from the perspective of the EPoSS community in the last few years here. And yeah, that's quite a story. And I'd like to show you a few of the highlights and also try to make a little bit of a link to artificial intelligence, of course. When we had the chance to ask people recently what they're expecting from a future transportation and mobility system, the answers were quite diverse. And interestingly, the topic of mobility is something where pretty much everybody is an expert. And this gives us great opportunities of trying to find out what people really expect and what really people wish to have for the future. There's three big paths that you see being mentioned there in most of the answers and responses then. And you see them here on the slides. It's about, of course, having a sustainable system that does not have too much of an effect on the world climate, for example, and the environment. They are dreaming of seamless systems, of course, that are convenient to use. And they're also referring to the topic of inclusiveness all the time, because in the end of the day, we all will be needing once in our life systems that are convenient and that are meeting our maybe even special requirements. And this is also like a common expectation in the community. I believe this is also the point that would probably be modified a little bit or could take into account expectations related to like the COVID-19 situations, that is putting people's expectations a little bit more even in the center of planning for future mobility. In the EPoSS community, we have recognized that smart systems permit and enable the transformation of the mobility system without such vision since long time, because they are key to enable green, integrated, interoperable mobility solutions. They facilitate taking into account the human in the approaches, and they support transportation, the transformation of transportation as a whole with technology transfer from auto into other domains. And you see this little icon here on the top right, which we have taken from our strategic research agenda with the smart system in the center. And if you consider all these roles that smart systems shall play, it's clear it is not sufficient to just consider sensing and actuation as the key functionalities. You also need to consider cognitive capabilities and linking the system into greater networks and bases of knowledge. And therefore, connectivity is playing an important role as well. From the perspective of the EPoSS community, we can serve all the big trends in future transportation, of course, be that automation, be that alternative powertrains or electrification. You see a little graph here that we once created where we saw, even if whether we talk about green vehicles or connected and automated driving, not just at the level of the applications there is SYNERGIES, but also in the bottom when it comes to sensing, perception, prediction, decision, controlling and acting. There indeed, a lot of similarities can be found in the architectures, in particular in the questions of making systems reliable, robust, maybe fail operational. Automated driving, I think, is a very good example of where you see the role of smart systems as enabling technology, and also as an enabling technology that can support a paradigm shift. Originally, we have developed that topic out of advanced driver assistance systems, assuming that there's more and more functions that the vehicle systems can perceive based on sensing, based on the sensor data fusion. And at the latest of that, a driver can, for a short time, take the hands off the wheel and the roads and the eyes of the road, and have the vehicle drive for a while till it comes to a point where it needs human support. But the interesting step is, of course, if you take the driver completely out and make the system self-driving, driverless. For that, there's more than just what the capabilities of a smart system in the vehicle can deliver. You need actually the embedding into greater data availability and knowledge sets. And this is also the point where artificial intelligence is coming in. Just to show you one example that I find the most striking one, that is the situation on the road. You have a person close to a crosswalk, and you have a super intelligent smart car approaching. The question here is not just what the car can perceive and what it can detect and maybe a 3D image, but the question is of what this means and what expectation the car system has of that situation. The crucial question here is whether that person will cross or will not. Because in the one case, the car, of course, needs to stop, and the other can continue driving. And of course, we want to avoid a car stopping all the time if there's just the slightest possibility of somebody maybe approaching the road, but rather we try to be able to tell in a trustful way what will happen, to understand the intentions of the road user. And here, indeed, the capabilities of smart systems themselves are quite limited, and we need to have additional information. We need to understand patterns. We need to know and take into account a big set of experiences, and that's where, from my perception, artificial intelligence will play a crucial role. Will help smart systems to gain trust in such situations in traffic. And you can imagine a lot of other situations on the road where the same will happen, because we are having an interaction between the technical system and the human system. Going a little bit further, urban Meyer mobility is another exciting field where smart systems pave the way to make that happen, particularly because we are making use and we're transferring experiences and knowledge from the car into the third dimension, whether that's electrified powertrains or whether that's automated control of systems. And again, this needs AI for the same reason. Maybe that's a bit also the role here of the EPoSS community to point to these needs and to show where the future directions are in. This has been well reflected in a lot of roadmaps and documents that were published in recent years, whether that's on the electrification of road transport, on automated driving, but also in our strong support to the European Commission in drafting the Strategic Transport Research and Innovation Agenda, the electrification of the transport system, the automation connectivity. One important aspect here is that, of course, the EPoSS community and their members, just in very little cases, are developing technology that you can directly put on the road. We are actually part of an ecosystem of enablers, which you see down here on the bottom, that is in interaction with an ecosystem of applications that needs to understand where are the technology pushes that we can define, and also what is actually the technology to be pulled according to user expectations from the application domain. And I think that's a very exciting interaction, which also the EPoSS community is very much supporting through the lighthousemobility.e of the Excel joint undertaking. Talking about Horizon Europe, because that's a very hot topic for the time being, of course. And currently we are trying to shape some of the discussions about future partnerships here. And Elisabeth already mentioned these three ingredients that you see here on the right side. So the KDT, which is the successor of the Excel joint undertaking, looking into all the building blocks of future applications, not just in mobility, but in many other application fields too. And then you see on the right side, on the one hand, the CCAM partnership that's looking into automated driving, and the 2.0 partnership for the zero emission road transport. Very clearly, while the building blocks are provided by KDT, the applications into the vehicle, into the domain of something you can put on the road is in the other two partnerships. So there's very close interaction, and we are happy to say that the smart systems community is facilitating this integration into the future planning. Just two more slides, one on CCAM very shortly, connected corporate automated mobility with the objective of leadership in safe and sustainable road transport through automation. Here in the clusters 5 and 2 that you see in the big circle in the middle, these are the ones that very closely emphasize the need of further innovations in technology. And number 5 particular is mentioning smart systems in it. Number 2 is particularly related to smart systems too. And number 5 also includes AI, by the way. And I think we took us quite some effort to always make sure that the community is aware of the fact that smart systems and AI are essential for the safety of connected and automated driving. If we would not have progress here, we needn't talk about validation or the integration to the transport system or any further demonstrations. The other 2.0 towards zero emission road transport very clearly again has a strong focus on vehicle technologies here. The link is, for example, through power electronics, but all the questions of energy efficiency of electrified vehicles using green energy, of course, will be supported not just by smart systems, but also by knowing how to use the energy in the most efficient way and making use of the knowledge we can gain through AI. Thank you, Nigel.